evening and welcome to Tinkering with Edkelar. First off, Happy New Year 2023 everybody! I hope your year had a good start. Mine was a bit of a mixed bag. Originally, I planned on a 1960s era portable turntable, complete with a tube amp in the case. But it turns out that it needs quite a bit more attention, not just a few caps. So, back to the old standby. Random test equipment. Back when I was troubleshooting the HP calculator, I pondered using some logic state analyzer to find the signals involved, but it turns out that that was simple enough to do with a scope. The idea, however, stuck with me and I picked up a vintage logic state analyzer. Not exactly the same period as the calculator, but still about halfway there. What we have here is an HP 1630G model. The 1600 series was HP's logic state analyzer suite, starting with the 1600 model in the mid-1970s. This one was released around 1983. The 1630 series had different variants, A, D and G, as well as a 1631 version which had a digital scope integrated too, sort of an early mixed signal scope. The general difference, however, is the number of logic channels available. The G version is the one with the most of the bunch, 65. Yes, not an even power of 2. The unit arrived in pretty good condition, but one of the feet got knocked off in transport. It actually broke off the aluminium frame. Hopefully nothing else got damaged in the impact. The bag that is screwed on the top is actually a required accessory. It holds the logic probe pods, in my case all 7 of them. They are semi-permanently attached to the base unit, so you need a place to stow them away for transport. For now, I have to unhook them. Both the cables and the bag are feeling a bit yucky, so good cleaning is in order. The case doesn't have any big scratches, but there is quite a bit of sticker residue all over. I need to address that. After a bit of struggling, I removed the cover panels and got my first peek inside. Wow! Quite a lot of circuitry in there. All the functional boards are slotted into a backplane, and then there's the CRT driver board and PCB that carries the buttons, which are connected via ribbon cables. The power supply board on top has been knocked out of its rail, further hinting at some rough transit. Oh, how cute! They mounted the power switch at an angle so the push rod would fit. The fan shows clear signs of the age of the device. Dust and extremely yucky residue. Might have been in a smoking or otherwise skunked up environment. Clearly worse than most of the rest of the device. The inner boards slide out without issue. An awesome assortment of chips on each of them. The main board, identified by the connections in the back as well as the CRT and keyboard connectors, is held in place by some more screws, but also comes out nice. One of the BNC connectors appears a bit loose though. To remove the power supply, the back panel has to come off. And after a few more screws, the front panel finally separates from the frame. Removing the CRT at last. It was a bit unnerving to work around it. And now for the cleanup and recapping. The power supply board holds the most caps, followed by the CRT one. The digital boards have next to no electrolytics, only a few tantalums across the power rails. Desoldering the caps on the power supply was a pain in the behind. Quite a few of them are connected to ground with at least one pin, and that is, again, like a heatsink. So, a double-wielding soldering. Now, I didn't see that the load of 1 microfarad caps are actually tantalums, so I ordered regular ones, which are a tad too big for the footprint. But while I wait for replacements, I'll use these. It's just filtering on the power rails, so no need to be too worried. Oh look, a reefer! I almost missed it, and it was already breaking apart. Now, here's again a good reason to always be suspicious of electrolytics. The 3 big blue cans looked perfectly fine, right? Look at what one of them had in store for me. Yuck! I first assumed it was some kind of glue, but then the other 2 were just fine. That stuff even ate away some of the solder mask. Brrr. For the CRT board, I got fitting replacement caps. One has me a bit worried though. I know that newer ones will generally be smaller most of the time, but this difference is weird. Same capacity, same voltage, bipolar, all adds up. Still, the replacement isn't even half the size. I'll better wear safety goggles when powering on. The keycaps come off with a slight pull, and the switches have a cover that pops off easily. Now I can clean the contacts and reassemble them. And here we go, assembling the case again. For some reason, HP found it funny to include a whole bunch of different lengths for the same diameter screws. Humph! The probe pods also deserve a good in-depth cleaning. They do open up, but if you do this, be very careful I didn't expect this, but all they contain is a huge ceramic hybrid. Very fragile, so clearly no components to replace here. I hope they all work. Reconnecting the pods too. I made sure to tag the cables and boards with the number of the pod to make sure they go together the same way again. There are 3 different types of them after all. And now, power on time. I first pull out all the boards and only have the power supply in it so I can tune in the voltages. Works out fine. 5 volts, negative 5.2 volts, all in order. Time to follow the alignment guides for all the other boards. The interesting thing here is that HP added a socket on the top edge of the backplane, so you can add one of the boards outside the unit without a riser board for servicing. Now that is repair friendly. The CRT alignment requires an external device that connects to the HPIB connector and triggers a test pattern screen. I don't have that, so I have to align it as best as I can with the regular screen content. And despite some serious burn-in, I have to say, the screen is crisp and sharp. Quite nice. And here's the moment of truth. One of the dip switches in the back has to be flipped when powering up to initiate an internal self-test. Will it work? Yes! That looks promising. Going through the menus to check what the thing can do. Various trigger conditions, combining bits to form words, display these words as ASCII or numbers. Nice. The only downside I see is that it requires a clock signal. It doesn't seem to support what I would call a free run capture, and that clock needs to be between 400 Hz and 25 MHz. It kinda limits the area where I can use it, but still, it seems to work. And you can even set the voltage levels individually for each pod. That's why there is an active part inside them. And after I received the bunch of tantalums, I replaced them on the power supply and rechecked the voltages. Again, some details for later. The pods have proprietary connectors and the unit didn't come with any probes, so I have to cobble a matching plug together, trying 3D printing first, of course. In the meantime, and maybe for some low effort measurements, I connect a few wire lugs together. That forms at least a 1-pin emergency adapter for the time being, so I can check if everything works as it should. connecting a clock signal, connecting a few address and signal bits, and last but not least, there's the lack of persistent storage. Every time you power up the unit, you have to reconfigure all the 65 pins for whatever measurement you want to do. Not practical. So I'm looking into the HPIB port next, as well as the HPIL for a tape drive that would allow to store the test parameters. And checking to see what I/O runs across the bus. Or, well, part of it at least. I didn't feel like making 40 of these adapters just yet. And that's it for this episode. Coming up, if nothing catastrophic fails, something mechanical again. At least the project is in the last steps of completion. Took me long enough. I started it in October. See you next time! Which are a tad bit too big for the damn it! Why is it called a footprint anyway? Shouldn't it be called a paw print?